Are we ready?
Yes.
So we are done with the discussion on defects of the human eye. Okay. Did you write down there
Yes.
the correction? For myopia, it is concave lens, and for hypermetropia, it is convex lens. The last thing that you have written is
Power of
accommodation. Yes.
stability of my idol.
Like I was telling you, why it is so essential to donate eyes. Okay, so there's a little bit regarding eye donation, right? And they're also talking about the different aspects wherein eye donation can actually help people without eyesight.
Very important.
So we are reading this passage now, right? Can you see? This one, this one.
Do you know that our eyes can live even after our death? By donating our eyes after we die, we can light the life of a blind person. About 35 million people in the developing world are blind, and most of them can be cured. About 4.5 million people with corneal blindness can be cured through corneal transplantation of rotated eyes. Out of these 4.5 million, 60% are children below the age of 2. So, if we got the gift of vision, why not pass it to somebody who does not have it? What do we keep? What do we have to keep in mind when our eyes have to be donated? Eye donors can belong to any age group or age. People who use spectacles or those operated for cataract can still donate the eyes. People who are diabetic, have hypertension, asthma patients, and those without communicable disease can also donate their
So you see that for eye donation, there's no need, there's nothing, there's no age restriction. Okay, even people who are suffering from different type of diseases like let us say diabetes or anything, hypertension can also donate. But who cannot donate is somebody who has got a communicable disease, like for example hepatitis, or somebody who is having AIDS. Okay, so such type of persons cannot be, they are not allowed to be donating the eyelids. Okay.
eye must be removed within 4 to 6 hours after death. Inform the nearest eye bank immediately. The eye bank team will remove the eyes at the home of the deceased or at the hospital. Eye removal takes only 10 to 15 minutes. It is a simple process and does not lead to any disfigurement. Persons who were infected with or died because of AIDS, hepatitis B or C, rabies.
Now these are all viral diseases.
What is B or C?
Hepatitis B or hepatitis C. So hepatitis is
cholera,
meningitis.
and encephalitis.
Yes. Encephalitis.
Cannot donate eyes. An eye bank collects, evaluates, and distributes the donated eyes. All eyes donated are evaluated using strict medical standards. Those donated eyes found unsuitable for transplantation are used for valuable research and medical education. The identities of both the donor and the recipient remain confidential. One pair of the eyes gives vision to up to 4 corneal blind people.
Did you understand? One pair can actually help 4 people, right? Two corneas and 2 lenses.
Now the person having cancer can also donate.
Cancer depends upon what stage it is. Cancer also there are of different types. So mostly they get cancer people who are having cancer. Okay. Have you heard of night blindness?
Yes.
What does it cause you? Can it be cured? Is it a communicable disease? What happens in night blindness? It's not a disease.
When enough light rays do not go in your eyes.
No, night blindness is due to a nutritional disease. Okay, do you understand? Just like we are having scurvy, which is caused due to the deficiency of vitamin C. Okay. Here it is due to the deficiency of vitamin A. So especially children in India are poverty, stricken children. They are the ones who suffer from night blindness. And if they are given a diet with the right amount of vitamins, especially A and D, they can be cured of night blindness. Have you followed? Why I'm mentioning this is sometimes you may also be asked whether this is due to a defect in the eye. Is it because of a defect in the eye? Definitely not.
Yeah.
Okay, it is only because of a vitamin deficiency, which can be very easily cured. Night blindness. Who are having night blindness? They themselves don't have food to eat. Very poor people don't have sufficient. But what about people who are life is lost during an accident? So many people who die in an accident. Just imagine the amount of corneas that we can actually harvest. It is said that Sri Lanka, that though it is such a tiny nation, it has got a maximum number of donations, eye donations. Right? So it has nothing to do with religion. It is more of an awareness that we need to talk about. The next thing that we'll talk about is
reflection of light.
The person was burned and died, so he can also do it.
burn में क्या होता है tissues are getting damaged. And depends upon, once again, if at all the person is dying of burns from the rest of the body, then maybe eyes are okay.
And like if the person died because he was in a death.
Once again, if at all the eye is not damaged, you can. Yes. No, if the eye is not damaged, then definitely yes. Okay, who wants to shift places now? Amongst the four of you. Anish is in his place. No problem with it. Now amongst the four of you, who is going to go there? Are we ready? We are talking about refraction through a prism. For you to understand how a prism actually looks like. Okay, it's a 3D, but what we are going to do is just draw only the outline of the prism. This is an equilateral prism because we find that these angles are the same. So if you are talking about ABC, which is a prism, and we find that these two faces are inclined. What is inclined? They are not parallel to each other like a glass slab. Remember glass slab? But now it is inclined. So we are going to see what happens if there is a ray of light. I'm drawing this figure now for you. Page 166. Okay. Suppose we are having a ray of light which is incident on this face AB. Okay. We are going to first of all draw a normal here on the face AB. Now for you to find out which is the angle, what is the angle? Is it this angle we are going to consider or this angle? My question, this is the question. Angle of incidence. Is it this angle that I am going to consider or is it this angle next to the prism?
Which is not next to the
This is the normal. I am drawing the normal. This is the normal and this is the incident ray.
So the one which is next to the
So the angle formed between the incident ray and the normal, or is it the angle formed between the incident ray and the glass prism? And the normal. Okay, do you understand? So incident ray and the normal, this is going to be your angle of incidence. Just look at the diagram in your textbook. Look at this diagram, everyone. Did you notice? Okay, angle I. Once again, you notice that it is coming from a rarer medium, and because this is glass, it is a denser medium. So this ray, instead of moving in a straight line, is obviously bending towards the normal. So the black line is the normal. So instead of going like this, it's bending towards the normal. So this is your refracted ray because it has been refracted. So there's a refraction taking place here, and this is your angle of incidence. Is everyone looking at the board? Now listen to it. Let's see what happens to this ray. Will it stay inside the glass slab or will it come out? It has to come out. From glass, once again it is coming out into the air. For us to understand, at this point, once again, we are going to draw the normal. Correct? And it's coming out by denser to a rarer medium. Instead of going in a straight line like this, it is bending away from the normal. So, this is the emergent ray. Why is it called as an emergent ray? Because it is coming out, it is emerging from the prism. So, there are three rays that we have identified. Incident ray, this is the refracted ray, and this is the emergent ray. Have you got it? If I am extending this emergent ray behind, I am just putting a dotted line here. It tells us that this is, now everybody is going to see this very carefully. Incident ray would have gone like this, but it has taken a turn and it has come out like this. Okay? So the angle which is formed here, this angle is what is known as delta, or they can also sometimes write it as D, which is your angle of deviation. Did you understand what is deviation? Deviation, just as a road, you are having a deviation of a road. What is happening? Incident ray is deviating, or it is taking a turn, or it is getting refracted. Therefore, the angle which is formed here is the angle of deviation. Yeah. Did you all follow? Okay. And this is something that we can take into the lab and show you how the experiment is actually done. Okay. So let me see if I have that.
A ray of light in a particular medium travels in a straight line, but when it travels from
Can you see somewhere? Prism. Now this is actually what is happening in the lab, so that you can see that. Can everybody see? Fast forwarding for you. Okay. See, first of all, you are taking the paper, you are using pins to stick it up, right? And we are placing. That is how the prism actually looks like, glass prism. And what we are doing is drawing only the outline of the prism. Correct? We have already drawn this. Can you identify?
Yes, ma'am.
Incident ray. Now, basically, this is the diagram which you are going to do by using pins. You are keeping it, drawing the outline, right? Using the protractor, you are basically marking it out. What is that now? The first line that you have taken on? That's the normal. See, that's the normal. So at the normal, it's just marking any ray. Which ray is that? It's the incident ray. Is everybody watching it?
Yes, ma'am.
Okay, now you are going to keep the prism back again. Are you eating something? If you are eating something, I'm going to throw you out of the class.
Mom is picking up the material.
Anyway. So what are we doing? We are using two pins and we are putting it on that side. And looking from the other surface of the prism, we are going to fix two more pins such that you can trace the path of light. Okay. This is what we do in the lab. Unfortunately, you people don't go to the lab, so that's why. So the person has come on this side of the prism. He is going to fix two more pins such that it appears to be in the same straight line. But is it in a straight line? No, because there's a refraction which has already taken place. Okay, but from this side, if you look, it appears that all the four pins are in the same line. I'll be asking you questions regarding this, okay? So please pay attention. Do you see that now? How it is appearing as if all of them are in the same line? But in fact, it is not. Okay. Now we are going to take out the prism and draw the outlines of whatever we have drawn. See? Why is it different? Why it's not in a straight line?
Deviation.
Correct. Basically, it is because of refraction. Okay, now you have taken it down. What is that P and the Q? Is it P and Q? Yeah. Those are the other two pins. That is it, emergent ray. Did you see that? Incident ray and the emergent ray. Then we are going to join that, showing you refraction which has taken place. What is the dotted line? What is the dotted line? If the prism was not there, light would have gone in a straight path. This is different. Did you see that angle B? That's the angle of deviation. This part we don't have. Drawing and plotting and graph. Sanja, everybody's got it. Understood how it has to be done. Now the same thing is explained to you. Let's read the experiment. Activity 10.1. Okay? Prashitari.
Fix a sheet of white paper on a drawing board using drawing pens. Place a glass prism on it in such a way that it rests on its triangular base. Trace the outline of the prism using a pencil. Draw a straight line PE inclined to one of the refracting surfaces, say AB, of the prism. Fix two pins, say at point P and Q, on the line PE as shown in the figure 10.4. Look for the images of the pins. Fix that P and Q through the other face AC. Fix two more pins at point R and S such that pins at R and S are the images of the pins at P and Q lie on the same straight line. Remove the pins and the glass prism. The line PE meets the boundary of the prism at point P. Similarly, join and produce the points R and S. Let these lines meet the boundary of the prism at E and F, respectively. Join E and F. Draw perpendiculars to the refracting surfaces AB and AC of the prism at point E and F, respectively. Mark the angle of incidence, angle I, angle of reflection angle R, and the angle of emergence angle E, as shown in figure 10.4.
Okay, so we look at the diagram. Did you understand which is the angle of incidence, angle of refraction, angle of emergence? Sometimes in the question papers, they will give you only a basic diagram, ask you to identify which is the emergent ray and which is the incident ray. One more thing, just as we are talking about light, always use these arrowheads. What does it tell? That this is the incident ray and that is the refracted ray and this is the emergent ray. What if I draw a diagram which looks something like this? Similar type of a diagram. Let us say, but I am showing it to you in the opposite direction. What will happen? Suppose I draw a triangle. This is nothing but a prism. And what if I show you this? What ray will that be?
Incident.
Very good. Because the arrowhead shows that the ray is entering into the prism. Once again, refraction has taken me. What is that ray? Refracted ray. What is this ray? This is your emergent ray. Is that okay? So be careful. Read the question paper carefully. It can be either this way or it can also be that way. Don't make a mistake. Suppose they are asking you to identify the incident ray. Don't say this is the incident ray. Did you understand? Look at the arrow. That will be the incident ray. Is that okay? Yeah. Continue, please.
Now, PE is equal to incident ray, EF is equal to refracted ray, FS emergent ray, angle I, angle of incidence, angle R, angle of refraction, angle E is angle of emergence, and angle D is angle of deviation.
Underline the angle of deviation. Okay, with respect to the diagram, they have given you different alphabets A, B, C, D. In your question paper, the same thing will not be there. They may give you something else, P, Q, R, S. But so you have to be careful. Next, that is the angle of deviation. Mark the angle of deviation in the above activity. So what does an angle of deviation tells us? It tells us to what angle the incident ray has actually deviated. Is that clear? Okay. Now we are going to be also talking about dispersion by using a glass prism. How many of you have seen such a type of a phenomenon? You would have seen, isn't it? Probably it is not a prism, but definitely when you are having a thick glass sheet, yes, you can also see.
I've seen with the pen.
Sometimes the
Scale.
even the scale, even a plastic scale, if you keep it at a correct angle, you will get. Sometimes on the CD also you can make out, isn't it? So that is nothing called as the dispersion of white light. So white light we all already see that it is made up of 7 different colors, and it was actually Newton. Isaac Newton, he was the one who has done a lot of work on light. Okay. So here again, what are we doing? We are taking a prism and passing a small beam of white light onto the prism. So when it is entering the prism here, what's happening? Refraction is taking place. That is, bending is also taking place. It's bending. Not only is it bending, but it is also breaking up into its constituent colors. Okay. So if you look at the constituent here colors, you have got all the 7 different colors which is coming up. Starting from B, I, B, G, Y, O, R. So right from violet to red, we have all these colors which can be plotted on the screen. Okay. And this is what is known as a spectrum. What is a spectrum? Where white light is broken up into 7 constituent colors, and that happens to be the spectrum. Can you see that? This diagram is also equally important, right? If this prism was not there, what will happen to the incident ray? So that is how we have to show with an a dotted line that if this prism was not there, white light would have traveled in a straight line. But because the prism is already there, there is a bending taking place. Remember to put these arrowheads showing that light is coming through the prism, it's coming out, okay? And you see that the violet light is the one which is bending most. isn't it? Okay, so that basically is what is known as dispersion. So dispersion is splitting up of white light into 7 different colors, and when these 7 different colors are caught on the screen, that's nothing but your spectrum. Correct? Who wants to read now? Read better. Dispersion of white light.
White light by a glass prism. You must have seen and appreciated the spectacular colors in a rainbow. How could the white light of the sun give us various colors of the rainbow? Before we take up this question, we should first go back to the refraction of light through a prism. The inclined refracting surfaces of a glass prism show exciting phenomena. Let us find it out through an activity.
Okay, yeah. What is the activity? Can anybody just read it? All of you will read because you have, yeah, all of you read it in your mind. I'll ask you questions. What are we doing? Okay. Ayush, can you explain?
Newton. This activity was done by Newton to prove.
Also, yes, not only that, even the disc. I don't know whether you people have read it in your lower classes. Okay, he has taken that disc and made those 7 different colors, and when you rotate it fast, it appears as if it's white light. Okay, so that was a very common experiment by which he was able to prove that white light is actually made of whites. Yeah, basically you can see that it is made up of white colors. Okay. Now, what was this experiment on? What have we done? Ayush, what is the experiment? This experiment about dispersion.
They make small holes in a cardboard so that a single beam of light.
Very good. It's a single beam of light. Okay. Then we cannot put a torchlight here. So we want only a point source. That's basically what we call it as a point source. Then
After that we keep the prism on where the light sources and see what happens.
okay, on the other side, what do we keep here? There's a screen. Okay, screen can be a white piece of paper also. If you keep a white piece of paper, you can write that the spectrum is. Okay. Next, the prism has
probably split the incident white light into a band of colors.
underline.
Note the colors that appear at the two ends of the color band. What is the sequence of the colors that you see on the screen? The various colors seen are violet, indigo, blue, green, yellow, orange, and red, as shown in figure 10.5. The
Acronym. Acronym is nothing but a short form.
figure will help you to remember the sequence of colors. The band of the color components of a light beam is called spectrum.
Underline spectrum. What is a spectrum? Underline that.
You might not be able to see all the colors separately, yet something makes each color distinct from the other. The splitting of light into its component colors is called dispersion.
Dispersion. Underline. What is dispersion? Basically, we have. Okay, now, did you notice one thing? When we are talking about 7 different colors, we start with your V and R, right? V, I, V, G, Y, O, R. Is V separate and I separate? When you are looking at green and yellow, is green separate and yellow separate? Or it is a fading of the green and starting? Yes. Basically, did you understand? It's not one particular band. So we can see a wide range of greens. Green is only not one particular shade. There are different shades of green, different shades of yellow. You see that? So that basically depends upon the wavelength of different light. Okay. That is called dispersion. Did you underline dispersion? Okay. Gaurav, please.
We have seen that white light is dispersed into its 7 color component by a prism. Why do we get these colors? Different colors of light bend through different angles with respect to the incident ray. As they pass through a prism, the red light bends the least, while the violet the most. Thus,
Violet light is bending the most. Red light is bending the least.
thus, the rays of each color emerge along different paths and thus become distinct. It is then band of distinct colors that we see in a spectrum.
Okay, so what is the reason? Okay. Let's see this. What is the difference between a refraction taking place through a prism and the refraction which is taking place in a glass slab? Do we get a band here? Do we get a band of colors? Yes.
Yes.
Do we get?
No.
We have already completed this, isn't it? Did we speak about the band of colors? Yeah. What is the reason? Just let it go. Look at the construction of the prism and look at the construction of the glass slab. What is the first thing that you notice in the shape?
This
Triangle.
density,
The density is the same. This is made of glass, that's also made of glass. The refractive index is the same.
the shape,
Yes, the shape itself. Did you notice that these two are parallel surfaces? Okay, incident beam here and the refracted beam is on this side, right? Correct? Okay. Here what is happening, incident rays here, because these two surfaces are inclined to each other, the refracted ray is coming down. Have you all followed? So the way the prism has been constructed, obviously it leads to dispersion, right? Clear till now? The next paragraph. Okay, that's an interesting piece. Have you all identified those lines, those two lines? Isaac Newton, the next paragraph, was the first to use a glass prism to obtain the spectrum of sunlight. He tried to split the colors of the spectrum of white light further by using another similar prism. So did you see the diagram? How many prisms were used? Two. Why did he use it? He thought maybe each of these colors can be further split, but instead what happened?
it became white again.
White. Okay, because the first prism is splitting into 7 different colors. The second prism, because it's inverted and it is kept, it is once again combining all the colors, and that's how you get white light. Okay. Read Gaurav.
Yes. From Isaac Newton. Isaac Newton was the first to use a glass prism to obtain the spectrum of sunlight. He tried to split the colors of the spectrum of white light further by using another similar prism. However, he could not get any more colors. He then placed a second identical prism in an inverted position with respect to the first prism, as shown in figure 10.6. This allowed all the colors of the spectrum to pass through the second prism. He found a beam of white light emerging from the other side of the second prism. This observation gave Newton the idea of that sunlight is made up of 7 colors.
Is that okay? Has everybody followed this experiment? Okay. Plenty of questions which are going to be asked from this part. All of them will be more or less experiment based. What is Anush writing? Anush,
Just practicing my right
practicing what?
hand. Right hand. So,
See here. Okay, page number 108. Right? Okay, now start writing. I'll give you a few points to write down. Right? I want you to write down I want you to identify these two points. Refer to your textbook. Start writing. First point. What will you write?
Myopia is a near-sightedness and hypermetropia.
That is another word for myopia. But I want you to find out what is the difference. Okay?
Myopia
It is due to elongation of eyeball
That can be
and
different. Yes.
A person
And
with myopia can
hyper-
see nearby objects clearly, but a person with hypermetropia can see distant objects clearly.
So first of all, for writing myopia and hypermetropia, you can also write down the common name here. What is the common name? Nearsightedness and farsightedness. Write down that. This is nearsightedness and that's farsightedness. Okay, so that's not a point of distinction, it's another name. Yeah. Now remember, whenever we are writing the distinction, make sure that the same point is repeated on the other side. You can't talk about the lens and you can't talk about some other point on the other side. If you're talking about the lens on one side, it should be about the lens on the other side. Right? So the first point, let me just tell you. Can you write, a person with myopia can see nearby objects clearly? Write the first point for myopia. Here. Yeah, a person with myopia. A person with myopia. It's even in your text. Take it up. Yeah. What did you write?
can see nearby objects clearly but cannot see
Cannot see?
far.
This
off
distant object
objects.
distinctly. Yeah. First line. 163. Myopia है ना? First line. Myopia. See there on the top. Yeah. A person with myopia.
We'll write the opposite.
Yes. Then you go to hypermetropia and see.
And see distant object.
For hypermetropia, you write a person with hypermetropia can see
Distant object.
distant objects clearly. Anush, read that point. Hypermetropia.
A person with hypermetropia can see distant objects clearly but cannot see near objects.
Nearby objects distinctly. Don't say he cannot see it. Of course he can see, but he cannot see clearly. No, it's not. What can you write about the second point? Point number A, B is given. You can use one of those points. Point number 1, point number 2. It is caused due to excessive curvature of the eyelids.
The image is formed in front of the retina.
ठीक है, you can write that. Myopia, in myopia, the image is formed in front of the retina. And especially when you're talking about myopia, you have to talk about objects which are very far off.
And then image forms in front of
And given that this defect can be corrected by using a concave lens.
That will be the last one.
Even the causes also, right?
Causes you have to write. Subpoint number 1 and 2 I told you.
Excessive curvature of the
Yes.
And
Myopia.
elongation of the eye.
Yes. Separate. Write it as two separate points. Okay. For myopia, you will write. Myopia is caused due to excessive curvature of the eyelids. So if there's an excessive curvature, what happens to the focal length?
Eyelids.
Ah, it decreases.
This is a curvature of eyelids or postmortem elevation.
Ma'am, in myopia, the image of distant object is formed, right?
Distant object is formed in front of the retina. That it should be given.
The event. What are the hormones?
Okay, boys, what did you write for the next point? Has anybody written? Excessive curvature of the eyelids, which causes the focal length to become what? Long or short?
Short. Long. Short.
Long.
Hypermetropia long. Elongation.
See here, if it is forming in front of the retina, Ayush,
Yes.
if it is forming in front of the retina, the focal length has decreased.
This can be corrected by using.
Very, very. You first finish the second point first. What did you?
Second, for hypermetropia, the focal length of the eye lenses is too long and eyeball has become too small.
Yeah. So after that, everybody is going to write about the shape of the eyeball. Elongation of the eyeball, and here the eyeball has become too small.
And then the last point will be concept.
So have you got 4 clear points now?
Yes.
Last point you can write.
Concave lens.
Yeah.
And
Myopia can be corrected by using a concave lens of a suitable focal length or suitable power. Okay, done? My next question. Okay, it's not given in your textbook, but please write down. What is a bifocal lens? Okay, what is a bifocal lens? And when can it be used?
persons suffers from poverty and
Correct.
like
Yes.
and the upper portion consists of concave lens, the lower portion consists of a convex lens.
Correct. My question is regarding bifocal. What is a bifocal lens and when is it used? See your textbook. Bifocal lens. Did you get the answer? Page number?
160.
Sometimes, did you get that? The person may suffer from both.
Yeah.
Yes. Take down the points from there. Shape what? Shape of one. Small, big geometrical word. Don't cut short these sentences because I'm stressing on those words. If you write an answer like this, probably I'll give you only half a mark extra. You understand what I'm saying? Boys and girls, students, listen to me.
Yes.
I'm stressing many points. Again and again, I'm stressing those words. If you cut short and write, you will lose out your marks. And don't say the teacher has dictated like this. I've never dictated like this. Correct your sentences. Arush, I want you to write, not think. If you are talking about the upper portion concave, why is it used? Lower portion, why is it used? All that you have to be written.
It facilitates distant of vision and near vision.
Oh, if you have written it in the same thing, it's okay. But what have you written? It consists of a convex lens, which helps you near vision. You can combine it there only. That's particular. Done? Karan, finish your done? Arush? Okay. Next one. What is cataract?
Gradual weakening of the ciliary muscles.
Cataract is not because of weakness.
Sometimes the crystalline lens of people at old age becomes milky and cloudy. This condition is called cataract.
Very good. And now can it be corrected? Can we take medicines?
Cataract surgery.
It can be corrected by surgery.
Yes, include that point. Done? Very good. Finish. What all did you write? It's cloudy, vision becomes less. Sometimes it can lead to total blindness. However, it can be corrected by surgery. Is that okay?
Sometimes the lenses people at old age because maintain this condition is not factor and this causes partial or complete loss. It is possible to restore the attack.
That's good. It can be rectified by that present. These are the answers that you can use in your own words because there's no law or statement. Okay, but make sure that you're using the correct scientific words. Next, I want you to draw. It looks like a simple diagram, but I want everybody to draw this. Prism and the spectrum. 5 minutes. Let me see whether it is technically correct. Yeah. You can use that diagram also. It is given there. Keep it in this. Or probably you can draw here, you can write some answer there. Make sure that it is an equilateral triangle. I'm giving you 5 minutes time. Hurry up, hurry up, hurry up.
Like this.
Is it coming out from the base? Wrong. So that's why I said it looks to be simple, but make sure it is correct. It will not come out from the base. Rub it out. Don't make it come out through the base. Don't make it. हाँ ठीक है वो थोड़ा और कम कर दे. Don't show a very big spectrum. Okay, make it narrow. Then it will fit in properly. Mention the colors. Arrowheads, colors.
Colors, how will I?
What? VIP? These are the colors. Right.
Slowly.
But what I'm saying is, what you can do is you are marking B and R. No? Show another few lines in between and put the divide over. You have it. You must get it when you B, R. Then you draw, do what you can draw all the things. Don't make this very big. Make it very close close to each other. And see here, this is long. Give me a pen or pencil, whatever. ये वाला refraction हुआ ही नहीं because you have taken a straight line.
Here it's
Oh, this one is it a straight line? Here itself is a refraction. See, this is not a straight line. This has to bend. Has to bend a bit. Huh? This is a refraction. This is A and this is here. The first line itself has to show a refraction. Make the change and don't make this extremely like a fan. It should look like a fan. Arush. Okay. Zero. Ah. What should I do? It looks like water coming from like a river.
This I have unable to understand. Why this is also
Last one, there should be a refraction. Okay. Look here, children. First of all, it becomes easy if your prism itself is large. Okay. See here. See here the mistakes that you have made. Right? First, I'm showing an incident ray, right? Draw the dotted line so that we can use this as a reference. Are you following? Girls, look at the board. Use this as a reference. So the first line that you draw should not be on this line. Why? Because there's a refraction taking place. So the very first line is going to be a slight bend. Correct? And draw the other one. Also, there will be a bend. I don't have a scale, so probably. Don't show like this and coming out through the base. No. Okay. So avoid doing that. And when it comes out here, further it is going to bend. This will bend further and there's a screen. So violet and red. That's all. Make sure that you put the travel heads. Draw the dotted line first. Maybe we can try to make it better. Right. Everyone has finished? The very common mistake is sometimes one of the mistakes that children make is, there's no bending here. If there's no bending here, that means there's no refraction. Avoid that. And the second thing is there's too much of, refraction taking place and it's coming out like that. That is also totally wrong. Correct?
So what do we have to find this?
Is everyone paying attention?
That will become my plane.
Now my question is, suppose a diagram like this is given. I want you to identify what is X and Y.
White light.
But we have the
X is
already.
Y and Y.
X
X is V, sorry. X is violet and Y is red. ऐसे हो रहा है ना?
White light
technology that
White light.
You see the arrowheads. Which light is this?
White light means
Incident.
Incident. This is incident.
White
So
light.
white.
This is white light. What's happening here?
Now there is no
conversion.
Refraction.
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 Refraction. तो यहाँ क्या हो रहा है?
Emergent.
Emergent ray, and at the same time there is dispersion. Now my question is, what is X and what is Y? Think. Here of course, and I'll just mark a little bit here.
that X is violet and Y is red.
X is
X is Y.
Ma'am, red and violet light
So,
is pass.
Yeah, so I want you to obviously identify which is violet and which is red.
X
Violet,
is
violet.
red and Y is
What did we say?
XV
Which is bending more? Which color? Violet. Okay, here which is bending more?
X.
X. Correct. Answer is correct. Correct. So it is the same diagram which is there in your textbook. Okay. Same thing, but they have given it like this. समझा ना?
Yes,
Yes, ma'am.
उल्टा करके दिया है. So
It's not going to be the same for the second one.
take down this question. Take down this.
0.6 is the same thing.
Sorry.
And 0.6 is the same thing. Not bigger.
One part of it. No. Not that part.
वहाँ
No.
पे वो mix
Here
करके
there
white
are,
बनता
that
है.
is different. There are two of them. I've drawn only one. Draw this. Take down this question. Boys. Hurry up. 5 minutes to draw. Finished? It's for you to recognize that such type of questions have been asked in the board. This is a board question.
Used
There's only two refracted. There's only one.
Inside?
Yeah. there is
Yeah.
one. Yeah. Only one.
What? Times. Have you finished? Good question here. What is the answer? Right. Identify. The question is identify X and Y. Okay, the next question. Okay. What is the spectrum? Write down. Spectrum.
X is the violet one and Y is the red.
The one that is bending more, we keep the violet, because we know that violet bends.
There is something known as doggy spectrum, I guess.
What?
Dog spectrum.
What is it?
I don't know. That is why we had heard it somewhere.
So we wanted to ask you.
I'll check on Google and see.
It is something with the coloring, but it is for different animals. I feel.
See, basically what I know is for the, this thing, no, when they have the bullfight. So have you seen those matadors? They usually have a red color, but it is, they cannot identify the red
They
color.
are colored.
So it's only the movement of the flag or the scarf that they have, they come and attack. I believe they're colorblind, totally colorblind. It's fine. Not very sure.
So it is just a superstition that everywhere red.
Yeah, it's the movement of the cloth which is actually in there.
The band is the color of water, the light green.
Correct, right.
No, my dog's color blind.
So I read somewhere that they can identify few colors. Few colors. More is it? More.
It is that snakes can see.
More through vibration. Heat is there and also through vibration. Suppose you're walking in the right
for
side.
them to see living organisms here. Because of
Heat sensors. That's why you're using an IR camera now. People who go in for wildlife photography, they use an IR camera. So even if there is some animal which is present inside the bushes or whatever, they can, because of thermal
we can see
sensing.
that.
Thermal sensing.
Let's see the cats, and you can see that sometimes their eyes are in circle shape, and sometimes they are.
It is actually a slit like that. Yes, a diamond shape.
Why is it like that?
The way it is
It's not
constructed.
only for
All cat
all cats.
all cat
I mean, dogs from you can see when they age, there's a white layer on their eyes.
There is a white layer on there.
For old dogs,
Yes, Robert.
maybe the one has
15, 16 years old. Yes, 15, 16 years old dog.
maybe you are having an old dog at home. Maybe.
I had,
Yeah, maybe because
I have 14.
14-year-old.
14 dogs.
14 dogs, yeah.
One by
14
one.
year old. Yes, 14 dogs.
मतलब full family.
She just lives here. She has
She's
14.
leaving.
Bullying, I guess, is
She just rescue.
Oh,
She has 4 cats and 14 dogs.
The rescues.
That's nice.
So let's finish this, boys. Let's finish. Spectrum. Spectrum here. Done. Very good. Next is dispersion.
Splitting of light into its component color is called dispersion.
Just one sentence. Come on, let's finish fast. Write down these two. Girls, have put up 2 questions on the board.
Second, let's all of that. How do we call it?
Have you written what is the If it is a 3-hour class. You have your textbook, so you go there. Complete these two answers are needed. Make sure it is there. There are 2 things to be written. Arush. Okay, the next question, Aya. Right, sir.
जंप मार के से बोले
Next question.
Okay. Some of the important ones. Okay. Now the question says, boys listen to me now. Okay. The question says, once again from your book you have given, the images formed in front of the retina, identify the defect and draw a diagram to show how it is getting rectified. You write down the question. Higher. I'm telling you, come on, write down. Image forms. Raj, I'm telling you the question. Raj, write down the question first. Image is formed in front of is formed in front of the retina. Identify the defect. And draw a diagram. Draw the diagram to show the correction. To show the correction. What is the answer? Myopia. Okay. How will you do the correction? By using
concave lens.
Concave lens. Draw the diagram to show the correction. What do you write? Draw a nice big diagram, don't make it small.
Pretty pen.
Is that one? The last one, yeah, the last diagonal. Vaishnavi, come on, diagonal.
ये correction for my opinion.
That's our question.
मैं तो कल मना ही कर रही थी मैं तो कल मना ही कर रही थी
Don't rely on that of Make sure that you are drawing the concave lens and the image should be formed on the retina. Why, Saria? First you draw the eye, then you draw the lens. And then don't show so much of divergence. Just have to see your diagrams.
Ma'am, do we have to directly draw it with the correction?
Directly with the correction. Only one diagram. See, after passing through the concave lens, you should show slight diversion. You are showing a straight line. You understand? It's a diverging lens, isn't it? So show a slight divergence. Now, even here, they are not given the proper diagram. You have to show a diagram. Who has finished? Anish has finished?
Yes.
Sure. This is where everybody is going wrong. See, when you are drawing the lens, okay, show that there is a slight divergence. Most of you have drawn like this. Freud, where is the eye?
No, I don't know. I just got it.
Construction in progress. Very annoying picture guy.
Finished? Okay, take down this question. Gaurav, if the bell rings and your diagram is not done, you are not leaving the class.
I completed.
Rose, are finished? Next question. Ready for the next question? Hurry up. Why is the human eye not able to see an object clearly if it is held very close to the eye? Very close to the eye. When an object is, see, listen to my question, that's why I'm saying. Why is the human eye not able to see an object which is held very close to the eye?
Now we can see it, but
Power of accommodation.
It's power of accommodation, yes. Talk about the power of accommodation, not myopia. Power of accommodation. Near distance is what? Near distance is 25. Okay? If any object is held closer than 25 centimeters, then your eyes are not able to focus. So that part is good. Rashita, what is your answer? You are not leaving the class if you don't finish. The bell is going to ring now. Hurry up. Shh. Hurry up.
The ability of eyes to exist to its focal length is called the power of accommodation, which is 20%.
So what happens?
So the human eye is not able to see the object clearly when it's
To see an object comfortably distinctly, you must hold it at about 25 centimeters from the eyes. The minimum distance at which the objects can be seen most distinctly without strain is the least distance of distinct.
So we talk about least distance of distinct vision. Arush, have you completed the answer?
yes.
Just 2 minutes left. Hurry up. This one.
To see an object
It's come from
today, both the ACs are both not working and the Ma'am, it's well told us that the bill was also not working. Thank you, ma'am.
Have you finished the answer?
Yes.
ma'am. But you should have to see the circuit out.
Yeah, it's all completely burnt out.
Yes, ma'am, fully black on this. Just like I was sitting over there, ma'am.
मेरे को उसके सीसीटीवी में दिखा नहीं बैठे थे क्या भैया अरे उसका आने का भैया सीसीटीवी चेक किया क्या आईसीसी वाले दिखे क्या क्या
आईसीएस का बच्चे
इधर आओ भैया नहीं नहीं फिर अभी देखो हमको नहीं बोलना फिर कि हमने किया हम जो भी है हमको बताना